Good evening, students. I welcome you all to my online class on numerical analysis. Today we are going to learn a new topic, solution of polynomial and transcendental equation. So first of all, what is the meaning of polynomial equation? Polynomial equation means it is an algebraic equation in the form of a polynomial having finite number of terms. Then in that case, that equation is known as algebraic equation or polynomial equation. And transcendental equation means an equation containing transcendental function. Transcendental function means you may get the trigonometric function, exponential function or logarithmic function, and this function contains infinite number of terms. So in case of transcendental equation, the equation having infinite number of terms. So there are some numerical methods by which we can find out the solution of polynomial and transcendental equation. So as you know that if you get a linear equation, suppose if we consider 2x plus 1 is equal to 0, then linear equation has one root. So in that case, if I consider 2x plus 1 is equal to 0, then in that case x, what is the root of the equation? X is equal to minus 1 by 2. And if you'll get a quadratic equation, then the equation has two roots. If you'll get cubic, 3 roots. If it is biquadratic, 4, and so on. So every equation has some roots in the field of real numbers. So here we are going to learn some numerical methods by which we can find out an approximate root or solution of the equation. So in general, many methods are available to find out the root of the equation, but in your syllabus the three methods, and these are some common method using to find the solution of algebraic and transcendental equation. So the methods are bisection method, then regular falsy method, and Newton-Raphson method. So today we are going to discuss about the bisection method. So let's start with the bisection method. Just look at the figure. So let us consider a function. So first we have to consider a function. So we have considered the function fx. That means we have considered an equation of the form fx is equal to 0. Now fx is equal to 0, it may be a polynomial equation, it may be a transcendental equation. Now if you say every equation, it is possible to represent with the help of a curve. Now this curve may be continuous or it may be discontinuous, but in this case we have considered the function fx is equal to 0, and we have considered, say, for this function fx we are getting this curve, and here the function fx is continuous between these 2 points a and b. That means the function fx is continuous between a and b, means it is continuous in the interval a and b. And see here, f of a is negative, f of a is the ordinate, and f of b is positive. So if you see this curve intersect the x-axis or touches the x-axis at one point. That means if f of a and f of b, they are of opposite sign, then the curve may touch x-axis at least one point, or it may touch this x-axis at any odd number of points. So if I take the curve this way, like this, and this, and if you come to this one, in that case the curve touches the x-axis at 3 points. So you have to remember, if f of a and f of b are of opposite signs, then the equation may have odd number of roots. That means it may have one root, or it may have 3 roots, 5 roots. That means it must contains odd number of roots. So what is the meaning of this? If f of a and f of b are of opposite sign, then there must be at least one root of the equation. So here we have considered, say, this curve touches the x-axis at this point, so we are considering this function fx is equal, this equation fx is equal to 0, at least one root. So now our target to find out the root of this equation. So in bisection method, what you have to do, we have to we have to make the interval closer and closer, and we have to come to this point. So how to do that one? So we'll take the help of the method of bisection. So in method of bisection, first you have to find out the first approximate root of this equation. So how do you find out the approximate root of this equation? Suppose this x1 is the approximate root of this equation. So the expression for x1, how do you find out? It is a plus b divided by 2. That means we are bisect this interval, no, ab. So a plus b divided by 2, that one will give you the first approximation, and that point is given by x1. So now if f of x1 is 0, then x1 is the root of the equation. But if f of x1 is not equal to 0, now see this figure. In this case, f of x1 is positive. F of x1 is positive. So in that case, x1, because f of x1 is not equal to 0, that means x1 is not the root of the equation. So now the root of the equation, say f of x1 is positive and f of a is negative. Now the roots of the equation may lies in the interval a x1 or x1 and b. But f of x1 and f of b, they are of same sign. So we know that if the product of two ordinates is negative, then there must exist at least one root. So now we can consider this way: the root of the equation lies between a and x1. Because why? Because f of x1 is positive and f of a1 is negative. So next, our target to take the next approximation. So how to get the next approximation? Suppose that one is denoted by x2. x2 is equal to what? Now we'll bisect this one, a plus x1 divided by 2, and suppose we are getting x2. Now x2 is equal to 1, a plus x1 divided by 2. Again you say f of x2 is not equal to 0. That means x2 is not the root of the equation. So again, if you see in the same manner, say f of x1 is what? Now it's negative. And you see here, just now we have find out f of x1, it is positive. So now we can say the root, at least one root of the equation, you will get in between x1 and x2. Because f of x1 and f of x2 are of opposite signs. So how to get the next approximation? So next approximation we have denoted by x3. So how do you find out x3? It is x1 plus x2 divided by 2. So now we are getting this 2 point x2. And see again, f of x3 is not equal to 0. That means x3 is not the root of the equation. But if you see earlier you are getting x1, then x2, then x3. Now if you see this point x3, it is coming closer and closer to this point. That means if you continue the process again and again, it is possible to come to this point. So if we continuing the process, it may help you to get the root of the equation. So this way to find out the root of the equation, or this method of finding the root of the equation, is known as bisection method. Now we have to discuss about the merits and demerits of this bisection method. So what are the merits? This method is very simple because here we are just bisecting the interval. So this method is very simple, and it is possible to write down the programming by which we can find out the solution of this equation. So first point you can remember, this method is simple and easy to computerized. Besides this, another merit we can say, this method is always convergent. See, when we are applying this method, we are coming closer and closer to this root. So this method is a convergent method. But this method has some disadvantage or demerits also. This method is very slow. It may say, to come to this point, it may take many steps. So we can say this method is very slow and time consuming. And another thing, this function fx must be continuous. If the function fx is discontinuous, then this method does not work. And another thing, f of a and f of b, the two product of the two ordinates must be less than 0. Then only this method works. So these are some merits and demerits of bisection method. So in next class, I'll take some examples and I'll show how to use the bisection method to find an approximate root of the equation. Hope it is understandable. Thank you.